Hello everyone, so we will solve another topic of fluid mechanics, chapter 6 fluid flow measurement from the book of Unisengel, Gen Simbala 6-41. So the weight of a water tank open to the atmosphere is balanced by a counterweight as shown in figure 6-41. There is a 4 cm hole at the bottom of the tank with a discharge coefficient of 0.90 and water level in the tank is maintained constant at 50 cm by water entering the tank horizontally. Determine how much mass must be added to or removed from the counterweight to maintain balance when the hole at the bottom is opened. So our illustration is this is the counterweight, and this is our water tank with the height of 50 centimeter and a 40 centimeter hole at the bottom of the tank. So our given, we have the diameter 4 centimeter, a discharge coefficient 0.90 and a height of 50 centimeter. So we are going to solve the how much mass must be added or removed from the counterweight to maintain the balance when the hole at the bottom is open. So our formula for the reaction force due to the momentum change using F equals density times the discharge times the velocity. Then for the discharge, we have discharge coefficient times the area, square root of 2 times the acceleration due to the gravity times the height. And for the velocity, using this formula, discharge coefficient, square root of 2 times acceleration due to the gravity and h. So first, we're going to solve the value of discharge. From the formula, discharge equals discharge coefficient times the area, square root of 2 times the acceleration due to the gravity times the height. So plug in the value, we have the 0.90 for the discharge coefficient discharge, and the area pi d squared over 4, or pi 0.04 meters squared over 4 square times the square root of 2, 9.81 meter per second square times the height 0.5 meter. Using our calculator,
Actual discharge equals
3.54321 times 10 raised to negative 3 cubic meter per second. Then we will solve for the velocity using the formula. This coefficient discharge times 2 times the acceleration due to gravity times the height. We have 0.90 times 2, 9.81 meter per second squared times 0.5 meter. Using our calculator, 2.82 meter per second. So here, we will plug in our discharge and the velocity. So for the formula of reaction force due to momentum change, we have force equals the density of water, 1000 kg per cubic meter, times the discharge, 3.54321 times 10 raised to negative 3 cubic meter per second, times the velocity, 2.82 meter per second. So using our calculator, we will get 10 Newton. So from this value of force, 10 Newton, force equals mass times the acceleration. Then rewriting this for the formula of mass equals force over acceleration. Mass equals 10 Newton, and 10 Newton is kilogram meter per second square over 9.81 meter per second square. So using our calculator, we will get 1.02 kilogram. So our the mass that we need or to remove from the counterweight to maintain the balance when the whole of the bottom is open is 1.02 kilogram.